In the last section, we understood how we can use examples as a common specification for everyone in the team, the business and the implementation members. Now, many teams might stop at this point. That is, teams will create specifications like these and continue with regular sprint activities. But then, this is not enough to be a truly successful team. What do I mean? Well, let's understand what happens in a typical agile sprint where the team uses specification by examples. Let's consider sprint N. During the sprint, the user stories are discussed. Acceptance tests are defined, like how we wrote as examples in the tabular format. Development proceeds with implementation with these acceptance tests as input to their development. At the end of sprint, product owner or someone representing business will execute these acceptance tests, maybe with the help of testers. He or she will accept the user story as done if the system demonstrates results as specified in the examples. In Agile Sprint, we repeat these steps for every user story. In the next sprint, we repeat these steps for new user stories. These user stories may be for entirely new features or enhancement of existing features. Whatever these might be, we need to ensure that we have not added defects in the system for the user stories that we implemented in earlier sprints. Then it becomes necessary to execute the acceptance tests for the previous stories. Executing them manually in every sprint is a big waste of time. It defeats the whole purpose of going agile because we are not being efficient at doing things. Therefore, it is necessary to automate these acceptance tests. Now you might say that we have unit tests and component tests to check for broken functionalities. Sure, these tests can be run, but execution of UT and IT does not guarantee that the system behaves as intended by the user. Acceptance tests are written from customers' perspectives. They test functionalities as seen by the user. Tests like unit tests can only tell you if you have built the product right, whereas acceptance tests will tell you if you have built the right product. Now that we are convinced that we need to automate acceptance tests, how do we automate them? If we automate these examples, like how we automate unit tests, we will have two tests, one in the form of the examples as written in the document, the other in the form of code. Now, can you think about the problems you would have if we automate these examples with code like the way we do UT or IT? Pause the video here before you move forward. I hope you did spend some time to think about the problems with automating the examples in traditional manner. What happens here is that the code we write to automate these examples is understood only by the developers. Now, keeping them in sync will be another task in itself. It will be similar to the problem that we already face when we have requirement spec and test spec as two separate documents. As products evolve with new or modified functionalities, we may or may not update requirement spec. Same with the test specification. Then comes a time where we find that the test cases executed from the test spec are failing. Where is the problem? Problem could be that the system has evolved, but the requirement spec did not change. So we did not update the test spec. Then we raise defect to update these two documents. Longer the age of the system, more is the number of such defects. And at one point we end up updating only these documents rather than working on delivering a product that satisfies customer needs. We will face the same problem when we have acceptance tests in the form of examples and then automate using code. As we add tests or modify tests, we may escape updating these example tables and modify only the code. At one point, these example tables will get completely out of sync from the automated code. You might say, this is fine. We will use example tables only in the beginning to arrive at a common understanding of our user story, and then use these examples as input for implementing the story. After we automate them, we will stop maintaining these examples. Any changes will be directly made in the automated tests. That way, we don't have to worry about keeping example tables in sync with the automated tests. However, in that case, we have a bigger problem. There is only code and no document. If we discard the document, there is no way that people representing the business side can look at these automated acceptance tests, as they mostly don't understand code. And even if they do, they just do not have time to go through the code to understand the system behavior. And this approach loses the huge advantage that we had. That was to have a common language to represent the system behavior. So to summarize, having only automation code as source of acceptance tests solves one problem, that is the problem of keeping specification and tests in sync. That's because there is no specification, only automated code as tests. But this introduced another problem, that people representing business do not have any document to refer to for understanding the system behavior. Then is there an alternate solution? How about instead of automated code, we keep our example spec as the only source? Well, we started like that. We just had example spec, but then there was no automation. Now we are talking about automating these examples. So how about using these same examples as automated tests? That is, we don't have separate code that automate these examples, but these examples themselves serve as automated tests. So we are talking about just one source, the examples that we write in tabular form as a specification as well as automated tests. Then both the problems that we discussed earlier are solved. We don't have out of sync issue because we have only one copy to maintain. Business people can access these examples anytime to understand the system behavior. They will always get the latest up-to-date specification of the system behavior. When we use these examples as specifications as well as executable tests, we call it executable specification. You will learn more about it in the next section. Now you might ask, how is that even possible? How can a document containing examples in textual format like this be used as automated tests? Well, that is where tools such as FIT comes into picture. FIT stands for Framework for Integrated Tests. It was developed by Ward Cunningham to help customers get involved in writing acceptance tests.